This is Mr. Carvajal, and today we're going to be going over word problems and how to analyze them using our cube strategy, creating a plan, and how to represent them. So our focus is going to be on the analyze, plan, and represent section of our problem solving math. If you need more help with the problem solving math, please refer to the video regarding how to use the problem solving math. Okay? So again, our focus today is using our cubes strategy for analyzing the word problem itself. And then for our plan, we're going to use the strategies that we've gone over in the classroom. They are on page 3 of your math journal. You can also refer to the video on how to use each individual strategy. So let's go first over the strategy cubes. In cubes, we circle the important information that will be used in our problem. That is part of our analyze. Okay, what are the important details of our problem? Okay? So that's our circling. We are going to underline the question only, nothing else. We're going to place a box around the key information that helps us determine the operation or the steps. The box section of the problem is what's going to be used primarily for determining the strategy that is going to be used for our problem. Okay, the key information is what helps us determine if we're going to be multiplying, if we're going to be adding, if we're going to be subtracting, if we're going to be dividing, if there's multiple steps. We're going to eliminate any information that is not needed. Any irrelevant information will be crossed out. Okay? And then we're going to sketch to create visual representations to help us in our understanding. That's the represent section of our problem. What does it look like? Okay, okay? So let's begin. We'll begin with this problem, which expression has a quotient of about 7. So here we're going to circle our important information that is going to be used in our problem. This is 7. Underline the question itself. So this is our question here. Placing a box around the key information, which helps us determine the in operation. So here we have the word expression, key information, expression, vocabulary term. We have to know what expression means in order to be able to properly determine the correct answer. Expression, and then key piece of information is quotient. This is our most important key information, quotient, vocabulary term. If we do not know what quotient means, there's no possible way for us to get the correct answer. Okay? And about, which means that we're going to be looking for an answer that is approximate or an estimate, approximate estimate. Forgot how to spell here. Approximate, it's an estimate. It's close to, not exactly. Okay? So quotient, as you can see, are multiple choice answers. We have division, multiplication, addition, subtraction. Okay, 36 divided by 5 is equal to 7 times 5 is 35. That is 7. 5 fits into 36 7 times, and there's going to be a remainder of 1. 2 times 3 equals 6. 5 plus 3 equals 8. 10 minus 3 equals 7. About 7. So it has to be close to 7. All of these answers are close to 7, except for D, which is exactly 7. So unless we know our key point of information, quotient, we cannot possibly solve the answer. Okay? So that's what our key information here is: quotient. Quotient is the answer to a division problem. So it's the answer to a division problem. And that is how we're able to determine that this is the correct answer and all the other ones are wrong, because in here, this is the product, this is our sum, and this is our difference. And this is how I'm justifying that those answers are incorrect and this answer is the correct one. Here we have workers at a company fixed 37,015 and 8/100ths of a meter of pipe. So our important information. Underline the question itself, which is, how is this number written in expanded notation? Next, we're going to place a box around our key point of information, which in this problem is written in expanded notation. If we do not know what expanded notation means, there is no possible way for us to get the correct answer. That's why this is our key. We have to know what expanded notation looks like so that we can get the correct answer. Now, eliminate information that is not needed and sketch. Okay? So, as we get into problems that have more details, then we begin to obtain information that is not needed and it requires us to sketch when there's multiple steps. As in this example, the rectangular top, so here's our the rectangular top of Caitlin's desk has a length of 3 feet and a width of 17 inches. What is the area of the top of Caitlin's desk in square inches? We have a student's name, Caitlin. There's only one student. So let's start by first circling our important details. Important details, we have 3 feet, that's the length. The width is 17 inches. Those are important details. Then we are going to underline our question itself. So here's our capital letter beginning our question. What is the area of the top of Caitlin's desk in square inches? Okay, and our question mark to signal our underline. Okay. Next, we're going to place a box around the key points of information that are going to help us create our plan, the strategy that we're going to use. Okay. So here we have a rectangular, that's piece of information that we need to know. Very important. Top of Caitlin's desk has a length of 3 feet and a width of 17 inches. What is the area? Here's our next keyword, area. We have to know the formula for area, how to find area of the top of Caitlin's desk in square inches. Extremely important piece of information, key to determining the correct answer. Okay? So that's our box. We're going to eliminate any information that is not needed. In this case, there's only one person, so this doesn't matter. The name, Caitlin, could have been Mark, could have been Susie. Name is not important for this math problem. That it was the top of her desk, it really doesn't matter for our word problem. It's irrelevant. Next, we're going to sketch to help us. Okay, so rectangular. We're going to draw our rectangular top. Check. Has a length. So what are we sketching? For our box, we determine that we need to create a rectangular top. We're looking for an area. And here is our plan of action now. We're creating our plan. We know that area can be found by multiplying the length times the width. Area is the inside of a figure. Okay? If you don't remember that area equals length times width, then our plan of action would be to go to our reference material sheet to find the formula. So our reference material sheet to find the formula, which is length times width, part of our plan. Next, we're going to be placing our important information in the proper sections of our sketch. We have 3 feet for our length. We have 17 inches for our width. And super important piece of information, the question is asking for the answer in square inches. So we cannot forget that we want the answer in square inches. We have 2 types of measurements. We have inches and we have feet. So part of our plan needs to include converting inches to feet, feet to inches. And this can be found in your reference material sheet as well. If you do not recall that 1 foot equals 12 inches, and how are you going to do this? Okay, so far, all we have done is we've analyzed the problem, we've created a plan, and created our representation. We have not started to solve. We haven't done anything up until this point. Let's look at another problem. We have Olivia has 2 gallons and 3 quarts of vanilla ice cream, and 1 gallon and 2 quarts of chocolate ice cream. So as I'm reading this, I'm looking for my important information, which is 2 gallons and 3 quarts of vanilla ice cream, 1 gallon and 2 quarts of chocolate ice cream. I have 2 different types of ice cream, so I need to be able to differentiate between the 2 different ice creams. So that's why the flavor becomes important. If there's only one flavor, that may not be important. Leftover from a party. Okay, leftover sounds important, but it is actually more than just important because it is a key piece of information that is telling me or helping me determine if I'm going to be adding, subtracting, multiplying, or dividing. So if it's left over, I know that at some point there was more. What's left over? So in order for my answer to get smaller, I either had to subtract or I had to divide. Not sure which one yet. Okay. That's my box. Now, underlining my actual question. Here's my actual question. What is the total number of gallons? Looks like this is a typo. Okay. What is the total number of quarts of ice cream that Olivia has left over? Okay. What is the total number of quarts of ice cream that Olivia has left over? Here we have leftover once again. What is the total number? Key information, quarts. Extremely important. They do not want the answer in gallons and quarts. They just want the answer in quarts. So as I'm creating my plan, I have to take that into consideration. So as I'm creating my plan, I have to remember that I need to convert my answer into quarts only. And I don't remember how many quarts are in a gallon. So I need to have a strategy for remembering that, which is my gallon land. The gallon king had four queens. Each queen had 2 pints. Okay, and if you don't remember that, then I'm going to go to my reference material sheet to help me find my answer, and I'm going to create my input output table. So you have multiple strategies. You're determining which one you're going to use, and that's the one that you're going to be writing. Okay. Next, we also have having technical difficulties here. Delete. All right, let's undo that. I'm not sure what happened there. Copy. All right. We started out with 2 gallons, 3 quarts, and 1 gallon and 2 quarts of chocolate ice cream. Okay. What is the total number of quarts of ice cream Olivia has left over? So we're combining both of these because she wants to know how many does she have left over in total. So even though leftover usually is telling us subtraction or division, in this example, we're trying to find out the total number of ice cream quarts that were left over. So if she has vanilla ice cream left over and chocolate ice cream left over, we have to combine them together to get our answer. So our plan is going to be to add our vanilla ice cream plus our chocolate ice cream, get our total, and then convert it to quarts only. BV used 3/4 of a cup of sugar, 3/4 of a cup of brown sugar, and 2 and 1/4 cups of flour to bake some cookies. What is the difference between the amount of flour and the combined amount of sugar used? Okay, so here's our question itself. That's what we are underlining, circling our important information. Now, in our question, we had key points of information. What is the difference? Difference, I know, means subtraction between the amount of flour. So I'm going to be subtracting the amount of flour from the combined. Here's another key point of information, combined. Combined means putting together, which means adding. So I have to add the amount of sugar used. So I have to subtract the flour from the sugar. And that's going to give me my answer that I'm looking for. So those are the key points of information that I'm looking for. So when I'm circling my important information, I have to differentiate between the sugar and the flour. So there's 3/4 of white sugar and 3/4 of brown sugar. So I have to add the sugar together. That's my first step. And then I have to subtract it from the total of flour. And I have fractions. So as I'm creating my plan is to add my sugar together once I get that total subtracted from the flour. Okay. For my visual, I can use either a fraction strip, and cut it into 4 parts to be able to add my brown sugar together with the white sugar together, get my total, and then start subtracting from the flour. I could also write for my plan. I have to remember that I am only adding or subtracting my numerator in a fraction and my denominator never changes. That's part of my plan. I have to know these pieces of information. Denominator. Let's move on to our next problem. Final problem. Mr. Carvajal bought 4 bags of candy. Sounds like important information. Let me circle that. Each bag contained 8 pieces of candy. Sounds like another piece of important information. 8 pieces of candy. He then placed, here's the word each. Each bag contained 8 pieces of candy. Now, each is more than just an important word. It's actually a key word because, as we talked about before, each could mean multiply or divide. So there's my box, there's my 2 options, multiply or divide. Don't know what it's going to be yet. I got to finish reading my problem. He then placed an equal number of pieces of candy into each of 9 gift boxes. 9 gift boxes, important information. And here's my other clue, my key word that's helping me create my plan. Equal number of pieces of candy into each. Okay, so because of this box right here, I'm able to determine that at some point I will have to be dividing. I will have to create equal groups. How many candies were left over? Here's my question. Underline that. My key point of information here. What section am I looking for? Leftover. So in my plan, I will be dividing, and in my division, I am actually looking for the remainder. That's what's left over. I'm not concerned about the quotient, I'm concerned about the remainder only. Irrelevant information, information that's not needed. There's only one person here, Mr. Carvajal. That's not needed. This could have been anyone. So I can cross that out. That I purchased it. It doesn't ask me anything about profit. Doesn't ask, so 4 bags of candy. Here's my equation. Here's my sketch. Here's my 4 bags of candy. There's my bag. Took me 5 seconds to draw it times 4 of them. So this is my candy bag. I got 4 of them. Each bag contained 8 pieces of candy. So inside of each one of these bags, there are 8 pieces of candy. So that word each is telling me that the number is going to get bigger. 8 times 4 is going to be part of my equation. 8 times 4, this is still part of my plan. My plan is to multiply 8 times 4. This is my visual that's helping me see that. Continuing on, he then placed an equal number of pieces of candy into 9 gift boxes. So first I bought the bags of candy. I have to figure out the total pieces of candy that I got. So that's my multiplication. And then I'm going to create equal groups because I'm creating 9 gift boxes. So then I have to divide. So that's my division because I have to put them into this 9 fancy gift boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's how long it took me to create my sketch. Quick, simple. This is not art. This is math. Okay. So this is to help you analyze word problems using the Q strategy. Use more than one strategy. Show your work, sketch, do your best, make mistakes, solve, and justify. Thank you.